Hello, so let's go through the chemistry holiday homework week 2. So you should have already done or attempted your holiday homework week 2, even though certain parts you can't do, it is fine. Even if some of your answers are wrong, it is fine, because at least you've tried for yourself. You have I guess used your brain and try to apply your knowledge into the different questions. So now let's look at the video and go through and learn from our mistakes. Okay, question 1. Okay, this is about purity. So I would like to start off with an example of water, because water is like the standard example, right? So water. So for water itself, drawing a number line here. So water boils at 100 degrees. Water melt at 0 degrees. So usually, a few degrees above and a few degrees below. So I'm gonna write the word impure. So impure substances is represented by the orange color. So impure substance will boil at 100 degrees to a few more degrees above it, whereas it will melt at 0 degrees to a few degrees under it. So that is the trend. So now let's look at this question. This question says compound Z, substance Z. It melt over a range of -49 to -50. It boil at 100. So the answer should be A. Because if the answer is if -48 and 98, it makes sense, you see. So boiling point until somewhere above, melting point and somewhere below. Similar to the example of water, so you can actually compare and contrast. That's why answer is A. Okay, question 2. Question 2 is about diffusion. Diffusion is affected by your mass, molecular mass. So the MR of H2S is 2 bracket 1 plus 32 equal to 34. The MR of SO2 is 32 plus 2 bracket 16 equal to 64. SO2 is pretty slow. So I can write it as SO2 will diffuse slower to the left of the glass tube. Then H2S diffuses to the right. So if I need to use an arrow to represent, so H2S go to the right very quickly, SO2 go very slowly. So answer is D. They will meet nearer towards SO2, and that's where the sulfur solid is formed. Yep. Okay, question 3 is a little bit challenging. So burette and pipette are essentially things we use to measure volume, which is actually, in a sense, idea-wise, is similar to the idea of a measuring cylinder. To measure something, measure a volume. Yep. You mean I can measure how much volume means I know when the reaction end? What? This doesn't link that way. Because some reactions, even if you know the volume, some reactions react very quickly, some reactions react very slowly. I wouldn't be able to know from the volume itself. Filter funnel is actually used to separate solid and liquid mixture. Again, separating something has nothing to do with whether the reaction has ended. So the only viable option is D. Why? Because all reactions would involve energy gain or loss. For example, I start off at room temperature 25 degrees. Oh, the reaction caused the thermometer to rise. 25 to 26, 26 to 27, 27 to 28. Then after that, it stopped rising at 28. It started to slowly go back to 27, 26, 25. So the point where it stopped rising and the temperature fall, that's where the reaction has ended. It stopped causing the thermometer to rise in temperature. That's the idea here. Okay, question 4 is tough. I have to say question 4 is tough because but it's okay. You look at your periodic table, the one I laminated for you. You realize that this is soluble, this is soluble, this is insoluble, this is soluble. So essentially you are just filtering a mixture of solid and solution mixture, which is just filtration. Question 4, if you don't understand, it is okay. We'll learn more in the next topic. It's just a teaser at this point. Okay, question 5. Benzene is... What is benzene? Well, at least I recognize the word solvent. Solvent means it is very likely a liquid that you dissolve something in. Example, water. Water is a solvent. Organic solvent. What comes to my mind is the idea of it's like oil or... Oh, okay. So you have a liquid, oil, something like oil, and mixed with water solution. They don't mix it. So what you essentially gonna get is two immiscible liquid. Immiscible means do not mix. So if that's the case, you'll use a separating funnel, then you'll evaporate to get the crystals. So it's important for separating questions to figure out what do you have first. Yep, so that's the idea. Alright. Okay, next part. Oh, they asked for what? Electron, not valence electron. So it's just a matter of counting. So Vr, look at your periodic table. Vr is 35. Proton number of 35. So Vr 35 electron. Vr minus, on the other hand, 36 electron. Chlorine has 17 electron. Chlorine minus 18 electron. At this point, you don't need to continue option A because they are different. They're looking for same. So don't waste time and do all three. So that's how it works. Interesting. Okay. Then, next. B is confirmed wrong lah. H minus H plus. H, F1 electron. H minus means gain. 2 electron. H plus is 0 electron. Clearly different. Lithium has 3 electron. Lithium plus is 2 electron. Neon is 10 electron. Again, different. Answer is D. Oh, I need to figure out what this is. Okay. So 18 minus and 15 plus, because 18 electron, 15. Oh, so it's X3 minus. 18 minus 16 plus. Y2 minus. So they are just negative ions. Cool. Yes, so that is how we do it. Alright. Okay, next we will look at, okay, so this is essentially just sodium, aluminium, and sulfur. Okay, so you're trying to figure out M2Q, M and Q basically. So M is and Q. M is your sodium. Sodium is group 1. Group 1 means 1 valence electron. Is it easier to gain gain 7 or lose 1? Lose 1 lah. So you get Na plus. Q is sulfur. Sulfur is group 16. 16 means your 16 valence electron? No lah, it has 6 valence electron. So is it easier to gain 2 or lose 6? It gain 2 electron. So S2 minus. Cross method, Na2S, which is M2Q. So this is true. Incorrect. So wrong. M3N. Answer is B. How can two metal bond together? Don't make sense, man. Don't make sense. C is true. Let me show you. N. Q. N is aluminium. Aluminium is group 13. Means 3 valence electron. Means I lose 3. I get Al 3 plus. S2 minus. Cross method. Al2S3. Which is N2Q3. Actually, this is also false. If you look at your S2, what? If you look at your laminated periodic table, certain elements exist as pairs. You have already highlighted those. This is not one of them. So actually, two answers in this case. Okay, next one. Oh, what happens when C and H form a single bond? It's essentially an electron each. Oh, so one line is equivalent to 2 electrons. So when you count them, you realize that you have 26 lines. Means there's a total of 52 electrons needed. Rather, not needed. They are used for bonding. Okay, so let's take a look at this question. So, okay, when it comes to this kind of unknown, right, I like to find out what the element is. I rather deal with known elements than unknown. So 13 proton represents aluminium. Q is 8 is oxygen. So just now we have figured out earlier on, right? Is Al2O3. So metal, non-metal, not covalent, they're ionic. How? So remember the formula? Mole equal to mass over mR. So mass equal mole times mR. So 1 mole times 22 bracket 27 plus 3 bracket 16. 102 gram. Oh, so answer is D. Yay. 24 gram of magnesium. So again, mole of Mg equal to 24 over 24 equal 1 mole. So I have 1 mole of Mg atom. Mg is alone, atom is alone. So Mg means alone. Cool. Okay. What about 14 nitrogen? Nitrogen is what? Is it N? So if you look at your periodic table, you realize that nitrogen is not N. Nitrogen is N2. Okay, cool. So the mole of N2 is 14 over 2 bracket 14 equal to 0.5 mole. So I have 0.5 mole of N2 molecule, which is not same. A is out. B, CO2. So mole, so the formula here is mole equal to volume of gas over 24 dm³ equal to 24 over 24 equal to 1 mole. So I have 1 mole of CO2 molecule. C, mole of I2, because it's molecule, 127 over 127 times 2 equal to half a mole. So you have 0.5 mole of I2 molecule. And lastly, zinc. What is zinc? Let's take a look. Zinc is 65. So mole of zinc, 2 mole. So you have 2 mole of zinc atom. So answer is B. 1 mole, 1 mole. Cool. Hey, next one. So many numbers. So what is hydrated? Hydrated simply means, it's like the example of you go into a swimming pool, you come out of the swimming pool, there's some water attached to you. Does it change who you are? No. So same thing, it's the cobalt 2 chloride with some water attached to it. Hydrated lah. So if the entire cobalt 2 chloride with the water is 476, the water is 216, what do you think is the mass of the cobalt 2 chloride? You minus off lah. So mass of CoCl2 get 260 grams. So remember your hashtag hack for mole. First step equation. I don't need equation here, it's not a reaction. So skip. Second step, change to mole. And third step, mole ratio. You realize that this will work even until your JC. Okay, let's change to mole. So mole of CoCl2 is 260 divided by, okay, need to check. Cobalt 59, sure. So 59 times, 59 plus 2 bracket 35.5 equal to 260 divided by, that's 71, 121, 130. 2 mole. Cool. Hey, there's another number, water. So mole of water is 216 divided by 2 bracket 1 plus 16. 216 divided by 18, which is 12. Last step, mole ratio. So mole of CoCl2 is to mole of H2O. 2 mole is to 12 mole. Two is to 12, 1 is to 6. Oh, B. Cool. So once again, the hashtag hack worked. Yay! Okay, let's move on. Question 2. Okay, wow, what's happening here? Don't panic. First thing, let's take a look. I look at the oxide. and I see that there's a high melting point. This is high melting point. High melting point. What bonding have you learned so far that is high? You learn metallic. You learn ionic. You also learn your giant molecular, which is a type of covalent lah. Giant molecular, if you remember, is your diamond graphite. Huh? Got what's this thing here? So this is out. Metallic means just a metal, no oxygen. So from this, I know that this is actually ionic. Ionic means what? Ionic means generally there's a metal and non-metal. If X2O, X2O, I know that O is group 16. O is O2 minus. So if you cross, so actually X is plus, because if you cross, you get X2O. So X plus. X plus means is going to be group 1. So group 1. Sodium, for example. Okay, next one. Why? Okay, are you going to change the color? So this is a low melting point. Low melting point, there's only one bonding. Your covalent. Or to be specific, it's the simple molecule. Covalent means all these are non-metals. Meaning O, Y. So it's essentially telling you that Y is group 17. Why? Okay, let's try. Okay, I will do part 2 first. So when you draw dot and cross, if you remember, most important question. When draw. Most important question is you figure out whether it's ionic or covalent. If it's ionic, you must have ion. Means I will straight away go and draw the bracket the charges. If it's covalent, then you think, So first, which is central atom? Means usually the one in demand lah. What do I mean? I mean, if you have one teacher and 2 students, slightly the teacher will be the center of the attention of the students, something like that lah. So in this case, Y2O means O is in the middle. Yay. Second step, how many valence electron? If you don't know how many you have, how are you gonna know how many you need? So if this is 17, means 7, and 6. So if I have 7 means I need one more, right? Okay, I form a single bond. So this one becomes 8, this one now becomes 7. 8, the other Y also wants 1. 8. Everybody is full valence. Electron shell, very good. And the last step is to show all valence electron. Third step is meant to counter any careless mistakes. 8. Ta-da! Can Y2O conduct electricity? Well, if you remember the hashtag hack, first step, tell me the bonding. Y2O is a covalent compound. What's the structure? NX has simple molecular structure. So if you recall, conducting electricity is just like me standing at the classroom door and maybe Elric standing at the corner of the class, the back corner of the class. I need to pass coil to him. I can't throw the coil to him, right? I need someone to pass the coil from me at the door to Elric at the end, which is essentially the same idea. So instead of coil, is charges that's being passed around. And instead of someone, what is the someone? So we'll say that Y2O cannot conduct electricity because it has no one. In any state. Why? As it does not have mobile ions or delocalized electrons. So delocalized electrons and mobile ions are the two things that can help so-called move the coil around or move the charges around, meaning conduct electricity. Oh, so this question is basically a standard question for bonding. Dot and cross, conduct electricity, melting boiling point. You see for yourself here, standard. So it's a melting boiling point question. Cool. Okay, let's go. This is X2O. So tell them the bonding first. X2O is an ionic compound. And Xis has giant ionic lattice structure, which means a lot of energy is needed. Needed to do what? Overcome your strong electrostatic forces of attraction between oppositely charged ion. You don't need to tell me what ion exactly. At least say oppositely charged ion. Therefore, X2O has a high melting point. Yay! That's it. Repeat for the other segment. I'm gonna copy. Okay, alright. Y2O is a covalent compound. So you only need very little energy in this case to overcome weak IMFOA, weak intermolecular forces of attraction between molecules. Therefore, Y2O has a low melting point. Quite standard lah. And the last question, mole calculation. Sure, let's take a look then. First one, it has mass. Oh, when you see empirical formula, what comes to your mind? You need to have this. Table. Okay, not that table lah, huh? Table. Meaning this. So the table, why a table? Table is to help you. Don't think of it as something to harm you. So a table, it is meant to allow your workings to be shown in a very nice manner. Basically more neater lah. So not percentage by mass. You are given mass in this case. Okay lah, then we write mass. Mass and percentage by mass, almost the same idea lah. Okay, let me find a calculator. Okay, found a calculator. So if you remember hashtag hack, second step change to mole. Again, it works. Last step ratio. Again, ratio. 1.12 divided by 12 is 1.12 divided by 12. 0.09333. So the answer got a lot of threes. You leave it as 4 sig fig. In between answers are 4 sig fig. 0.187 divided by 1 is 0.187. 1.49 over 16. Let's see. 1.49 divided by 16. 0.09313. 4 sig fig. Then after you divide by the smallest. 0. Oops. 0.09333 divided by 0.09313 is basically 1. 0.187 divided by 0.09313 is 2. 0.09313 divided by 0.09313 is 1. Therefore, empirical formula is CH2O. Oh yay, cool. Okay, last step is basic. Last question, sorry, is to mole lah, skin mole. So it's actually a continuation, right? So let's look at the numbers. I have two numbers here. They give you number, they expect you to use lah. So the formula here is mole equal to volume of gas over 24 dm cube. And mole equal to mass over mR. Cool. So they say what? They say find the mR. And hence the formula. So find mR first lah. So I try. Mole equal to 0.125 divided by mR. I don't know my mR. I don't know my mole. I cannot use. Then don't use it first. Mole equal to volume of gas. This one you know. So trick, trap. Must change volume from cm cube to dm cube. It's a very common trap. How do you change that? Don't need to panic, because cm cube is essentially milliliter and dm cube is liter, so you can just divide by 1000. So equal to 50.0 divided by 1000 divided by 24, which is, let's find a calculator and calculate. 50 divided by 1000 divided by 24. 0.002083 mole, again for SF. Then after which, now I got mole. Then you can use the other formula. Mole equal to 0.125 over mR. mR equal to 0.125 over 0.002083. 0.125 divided by 0.002083. 60.01. Okay, then you have the MR, which is this. Okay, MR, yay! So you can find the molecular formula. So the molecular formula is essentially a multiple of the empirical formula. What is the multiple? I don't know. It could be 1, it could be 10, it could be 100. So that's what we're supposed to find out. So let's try and find out. Empirical formula is CH2. Let's find out how heavy is CH2. CH2 is 12 plus 2 bracket 1 plus 16 times the multiple equal to 60. So the 30 times n equals 60. So n is 2. So therefore, it is a 2 times multiple. So the molecular formula is just C2H4O2. So yeah, that's about it.